Today, we're going to be writing expressions for visual patterns. So here's a visual pattern, a little bit of a harder one. We're starting with a tough one. And in figure 1, you'll see it has 1 block. And in figure 2, it has 3 blocks. In figure 3, it has 1, 2, 3, 4, 5 blocks. 1, 2, 3, 4, 5, 6, 7 blocks. So you can kind of see what's going on here is that we're adding 2 each time. So by the time we got to this one, we've added 2, added 2, added 2 3 times. So this 7 was really added 2, added 2, added 2, that many times. And so this repetitive addition is going to show up in our equation as a multiplication. You'll notice that the very first one we did not add to, and that's going to create a little bit of tweakiness in our problem. So this one we'd added to this many times. This one, the third one, we'd added to twice, and so forth. So what would the eighth one be? Could I just double this? Would that work? Well, let's see. Did this work, just doubling 2 to 4? No. So it's not linear. These are not going to be linear where you can just say, look back at this and just double it to go on. The rule's going to be more complicated to that. When we were dealing with linear expressions, it was just multiplication. Here we're going to have multiplication and addition or subtraction. And what you're going to find is that this repetitive addition number is going to show up in your answer as multiplication. We are multiplying by 2 each time that we're adding it on repetitively. And we'd like the rule to just be timesing by 2. So let's just see if timesing by 2 works. Does that work? No, that would give me 2. That would get me 4. That would get me 6. That would get me 8. But it gets me close. Did you notice that all of these were just 1 too big? What if I multiplied by 2 and then subtracted 1? That is our rule. That is the one that works every single time. So looking at 8, if we times by 2, we'd get 16. And if we subtracted 1, we'd get 15. If we were talking about 20, we'd times by 2, which would be 40, subtract 1, and that would be 39. Go ahead, draw it out if you don't believe me. Draw out the eighth figure, and you'll see that it has 15 squares in it. So my expression would be times by 2 and subtract 1. This subtract 1 has to do with the fact that on the very first figure, we did not add 2. We only added 1. So that's where we get the minus 1 from. We're 1 short. Notice when I plug in 0 to here, I wouldn't get 0. This is not linear. If I plug in 0 here, I actually get negative 1. How would that look like? It's like you're short a block. You're missing a block. So this is our answer. This is what we are adding each time. And in each of the examples, we're going to see that repetitive addition becomes the multiplication. Let's go on to this one. This one's usually easier for most people. So in figure 1, I have 4. And in figure 2, I have 5 down here, 6, 7. And then in here, let's see, I have 7, 8, 9, 10. I have 10. Can you kind of see the growth rate that's occurring? Here, I'm adding 3. I'm adding 3. Can you see that on the next one, I would add 1 here, here, and here again. So that would take me to 13. So I could keep doing this to figure out the 8, but that's too slow. I want to think of a rule. And do you remember from the last one that we did? That repetitive addition becomes the multiplication. By the second figure, I'd added 3 2 times, this one here and this one here. By the third figure, I'd added 3 3 times. Here's the 3, here's the 3, here's the 3. Side, top, side. Okay, but does that work? I'm adding 3 each time, but does multiplying by 3 by itself work? No. We're going to see this a lot. They're not linear. There's more to it than just, they're not proportional. There's more to it than just multiplying. Timesing by 3 would get me 3. Timesing by 3 would get me 6. Timesing by 3 would get me 9. Each time I am short 1. So I need to add to my rule times by 3, add 1, times by 3, add 1. So my rule here is going to be times by 3, add 1. That would take me to 25. Times by 3, add 1, 61. Where is this 1 coming from? Can you see where that 1 is coming from? It's the very center one. Here's the 3 I added on each side. Here's the 3 I added on each side, but there's that 1 in the middle that started there. So our expression answer would be times by 3 and add 1 for that 1 in the very center. Let's do one more example. Okay, so figure 0, we could talk about, figure 0 here. If you went back 1, you could talk about it. It would have 1. This one right here, it would just have that 1 in the center. Okay. Okay, figure 0, figure 1, 2, 3, 4, I guess 8 and 20. Okay, figure 1 has 3, figure 2 has 5, this one has 7. Okay, I'm getting faster at these. This is adding 2 each time. The repetitive addition is the multiplication. So the rule is timesing by 2. Let's see if that works by itself. See if the rule is just proportional. No, timesing by 3 doesn't work. Timesing by 3 doesn't work. What would work? What would I need to do to make the rule actually work? So timesing by 2 has to be there. What would I need to get to 3? Well, I need 1 more. What would I need to get to 5? 1 more. What would I need to get to 7? 1 more. So the rule is times by 2, add 1. Times by 2, 16, add 1, 17. Times by 2, add 1, 41. So there's my answer for the expression, times by 2, add 1. So where does the 2 come from? The 2 gray trees that are being added each time. Where does the 1 come from? That 1 black tree right here. And these could be boxes, they could be stars, they could be anything. They just use trees in this case. So hopefully a couple more examples got your brain working so you can make it through your assignment.